Okay. So right now what you see up here is, I'm going to go through the syllabus and everything else, but just to give you an idea what I meant by that about how I do notes. This is yesterday's lecture that I did in one of my other classes. So I'm writing, talking, highlighting, and then that video will be available later. And then you can also take everything I write down here. I'll put it on our website on Canvas as a PDF file that you can print out. Now, that's the way I would like to do this class, but I'll be honest with you. To me, it sounds like the greatest thing ever, right? But that's me. I like technology. It might turn out that after a week or two, you all just want me to be up on a board like a traditional lecture. I'm not recording anything. I will ask you as we go. We'll just take a poll. We'll see how everyone feels. Because sometimes this is, it's a little dark in here and, people kind of get disconnected. So right now, this is what I'm going for. That make sense? Okay. All right, let's get back to the syllabus though. Oh, I didn't introduce myself. My name is Robert. And then last name DiGiovanni. If you've ever, most people have heard the word Giovanni. So just put D-I-D in front of it, DiGiovanni, all right? So that's me. You can call me anything respectable, it's fine. All right, I'm assuming everyone knows how to log into ACES, okay? If you don't know how to do any of what I'm showing you here, just, talk to me after class. So you log into ACES, right? And once you get there, you can get to your classes. I forget my password. I think that's it, yeah. Right, you get here and then you click on My Courses, right? And then from there, you go, make sure you're in spring, you go down to your classes. You should see one here. It's Elementary Algebra 0310, right? It should be the only math class you're taking. And you click on that. Has anyone done this yet? A couple of you? Okay, this is the page. Right now, this is like our class home page, all right? Right now, the only link I have right now is to the syllabus. After today, it'll look more like this, like my other class. A link to the syllabus and then a link to the lecture. So that's the link, the video I did for that class the other day, right, yesterday. So that's what yours will look like. So what I'm going to do is I'm going to go through the syllabus. We no longer hand out the syllabus, okay? Everything is electronic. So I have to do this. This is kind of like my contract with you, so it's important that I go through all this information first day. So first thing, we meet Mondays and Wednesdays from 9:30 to 10:45. You're in the right place. The math department is on the second floor of this building, room 213. If you ever need to go to the math department, in fact, today you are going to go to the math department, even though you didn't know that. And I'll explain to that. I'll explain why you're going to go there. But room 213 is where you're going to go, all right? And that's just go down these steps over here and just come off the steps and take a little U-turn. There's a little corner room right there, all right? And there's the phone number for the math department. My name, again, Robert DiGiovanni. A little bit about myself. I've been teaching here since, in some way, shape, or form, either tutoring or teaching since 2000. So I've been here for a long, long, long time, it seems like. The years are just adding up. So I teach full-time here, so I'm not a part-timer where I do one class here and then I leave to another school or something. This is my career, all right? I teach math. So that means you can find me here when we're not in class. In fact, we have my office location is on the first floor of this building. That's my cell phone number. If you need to get in touch with me, just call my cell phone. You can also send me a text. All right, text me. Just if you text me, make sure you tell me who you are and what class you're in. Okay. If you text me, say, hey, what's the homework for tonight? I have no idea who you are. Okay. I have 7 classes, so I can't very well just guess who you are. Now, once you establish that first text, I should be able to go back and know who you are later. Just that first one, let me know who you are. All right. Now, some people think it's kind of weird that I won't text my instructor, but I teach 3 internet courses, so all my internet students have my cell phone number, so I may as well give it to you too. I mean, it's not a big deal to me. I want you to know that I am easy to get in touch with if need be. All right, office hours. Let's take a quick little vote or poll here. How many of you, this is first time in college, like this is your first semester? Okay, so there's about half of you first time. So I'm going to go through this like, for the others here, just bear with me. I'm going to go through this like everyone doesn't know this is first time. Office hours. What are office hours? Anyone? What are office hours? Every professor has one, has office hours. What are they? Whenever I'm available to you and to any of my students, all right? So I teach 7 classes, 3 of them are internet, 4 of them are face-to-face. So I do 2, on Monday, Wednesday I do 2, Tuesday, Thursday I do 2. So after this class I have a break until 1, then I teach another class. So if you put all my breaks together, I'm supposed to have 10 hours of office hours that you could come see me. And here they are. So Monday, Wednesday, I don't have anything before this class, but I will tell you I'm in my office usually by 8:45. All right. So we meet at 9:30. I'm not putting on a paper, but normally I'm in my office from 8:45 to when this class begins. Definitely there by 9:15. So if you needed to get in touch with me before this class, you could. But then immediately after this class, I walk down to my office and I sit there and I surf the web and I watch crazy YouTube videos and stuff for 2 hours. All right, waiting for students to come in for help. Just sitting there waiting, looking out my door, nope, waiting. And you either come or you don't, all right? For 2 hours, you've got it. Now, hopefully that works into your schedule. If it doesn't, then I have more hours. And let me describe to you real quick the way the office looks. What it is if you're looking from the top, it's like a hallway, and there's like little offices off to the sides, right, with the little doors and stuff. And then in the center, we have a bunch of tables. And those tables are open tables. So you can actually go into my office location area, go sit at a table, and just break out your math work and just start doing homework. And that's what I encourage you to do, because if you do that and I'm in my office and you have a question, you can just come over there and I can help you, right? Or if it's something you really need help with, I can go sit down with you, and help you out. And I've also worked out kind of a deal to, there's I don't know how many faculty in this office, but there's a lot of math faculty here, and we kind of have a deal like if I have a student that needs help and I'm not there, they'll help them, or if I'll help their student, and we help each other out. So you should always be able to get some sort of help there if need be. All right. So Monday, Wednesday, right after this class for 2 hours, then I teach Calculus 3 at 1 o'clock. So from 1 to 2:40, I'm in Calculus 3. Then I get out, and then I teach. I'm in my office from 3 to 4. So I've got another hour later on today. And after that, I'm gone. I'm out of here. Tuesday, Thursday. I know we don't meet on Tuesday, Thursday, but maybe you have a class on Tuesday, Thursday. I have some other hours that you can come and meet with me. And then on Friday, I'm scheduled to be there from 9:30 to noon. But I will warn you, on Fridays we have departmental meetings. Okay, so sometimes I'll have a meeting at 11 o'clock, and so I can't really commit to those times. So I always say that if on a Friday you plan on coming in, just shoot me a text or email. Just let me know you're coming. Say, hey, do you have any meetings, anything like that? That way you don't come and you're all disappointed that I got pulled into something. Okay, that makes sense on Friday. So Friday's kind of a little asterisk there. You know what? Y'all have enough room there? You okay? All right. We can move, kind of slide tables around if we need to. I believe if you add all these hours up, it's more than 10. Because this right here is 2 hours, but then it's both Monday and Wednesday, so that's 4 hours. 5, that's 6. 7, 8, 9, 10, and then this, yeah, it's like, I don't know, 14 or 15 hours. Okay, I have good news and I have bad news, all right? What do you want first? Bad news? You're in a math class right now. I mean, that's bad news, right? Now, the good news is that you don't have to buy anything for this class. This is a pilot class, meaning that the state, that means Texas, has changed the way developmental math education is structured across the state. It used to be 4 courses. 0300, 0301, 0302, and 0303. Used to be 4 semesters possibly of developmental math. And you would take a test and you would see which of these you placed into. Then after that you do college algebra or whatever, okay? That's the way it used to be. And then the state came down and said, you know what we're going to do instead is we're going to take those 4 courses and we're going to consolidate them into 3 courses, an 0305, an 0310, and an 0320. And then students will place into one of these 3, and they change the scores and what it takes to get into these. And basically what they've done, I should probably pause the video for what I want to say here, but I won't. I'll just say that I'm not very happy. A lot of us aren't very happy with this, because what it's done is it's basically forced us to take almost 4 semesters of material and cram it into 3 semesters. And the 2 courses that get hit the most are yours and the one after this. We are going to basically be doing a lot of what this course and this course would have done in 2 semesters. We're going to be trying to do it in 1. And it's going to be, this is the first time we've tried it. There's only 2 of these classes being offered right now. I'm teaching one, and then there's another instructor doing the other. So we were the ones that raised our hand. We're like, I'll try. You know, someone has to be the first one to teach this class. What you have to keep in mind is we have a schedule, a list of topics that we are supposed to cover. And it's going to seem fast. And that's just, you go write your congressman about that. Okay, that's just what we have to do. So just I want you to understand that that's kind of like what you're walking into here. Now, the good news on it, because you're like, where the hell is the good news? The good news is that because it's a pilot, the publisher of the book gave us classroom copies. So everyone gets, unfortunately it's not a hardback, it's actually 3-hole punched. This is the book. You're going to have to go get a binder. Okay, that's the only material you need for this class. A binder, 3-ring binder that'll fit this, okay? You go put it in there. I do expect this back at the end of the semester. All right, that sound fair? Okay. Even if you drop the class, or something like that, you know, just out of respect for everyone else, turn it in. You know, I mean, you don't need it anymore. Some other student can use this. Our plan is to put these in the library for students to be able to check out at some point. So what you'll need to do to get this free copy of the book is to go to the math department, which is room 213. I'll write it on the board again. It's room 213. Juniper Hall is where we are, room 213. Just walk in there, tell them that you're there to get your free textbook for your 0310 class, all right? And there's a little conference room in there, and they've got a bunch of boxes, and they're full of these. Just go take one. They're not, I don't even think they're asking you to like sign anything, or just go get your copy, okay? Everyone good? All right, let's see, continue with the syllabus. So that's what we need. No one bought anything, right? No one got a book yet? You did? What'd you get? Can I see the front of it? Oh, no, it's all covered? Is it McKenna Kirk? Let me see. Yeah. Okay, yeah, you won't need that. Did you get it here? You bought it here? Okay, well, you know, yeah, the bookstore may buy that back from you, or you might be able to return it. I'm not sure. But you get a free book, so you don't have to buy anything else. I guess that's the good news there. Okay, course description. I will talk about the course description a little bit because it is quite a bit of material. We have the algebraic expressions, linear equations, and inequalities in one variable, graphing linear equations in 2 variables, systems of equations, exponents, polynomials, and basic factoring. That is a lot of material. That is a lot of material. And what we have to do is the state says this is what the course needs to cover, and then we have to find a book that will cover that, and that's what we've done. And then we have the outcomes. These 7 outcomes are the things that every student needs to be able to do, you know, to be able to successfully get through this course. There's 7 things. Again, that's a lot of material there. It seems like, 7 things, yeah, no big deal, but it's a lot. The grade, this is a developmental math course, so the only thing I'll point out here, you know, standard grading scale A, B, C, D, F. That's standard grading. 90 to 100 is A, 80 to 89 B. But in a developmental class, you have to have a 75 or higher to pass. So a 72 is not passing in this class. D's are not considered passing in developmental class. So the D and the F are almost the same thing in this course. It's either pass or fail. That's really what it is. It's just you can pass with an A, pass with a B, or pass with a C. Anything other lower than a 75, you have to retake the class. Now, a breakdown of how we do the grade. You have a lab, which I'll explain here in a second. That's 5% of your grade. We're going to have quizzes. I plan on having quizzes almost on a daily basis. The quizzes can come in the form of you walk into class, here's a quiz, or it could be in the middle of the class, here's a quiz, or it could be at the end of the class, here's a quiz. They could be just you. It could be you and your table. It could be open note. It could be open book. It could be pretty much anything I want it to be. It could be attendance. I could say it's a quiz today. So just keep in mind that 15% of your grade is going to be determined by all your quizzes put together. I will drop 2 quiz grades, all right? So you get, you know, if you miss a class and we had a quiz that day, well, that's one of your drops, you know, just that's life, it happens. Now, you also have 4 exams that take place in class. Now, our class is an hour, 15 minutes long. So those 4 exams are worth 15% each. You have an hour, 15 minutes to complete the exam. Add them all up, that's 60% of your grade. Then you have a final exam. And again, for those of you first time in college, the final exams occur in the last week of the semester, and they are not, they won't be an hour, 15 minutes long. They'll actually be 2 hours, 45 minutes long. That's how long we'll have for the final. So that's why it's worth more. When we get to the end of the semester, we'll talk about what would be on the final. Right now, I can't tell you, right? But it could cover everything. It could just cover a little bit at the end. Usually my mentality is that if my students do well on the exams leading up to the final, then the final shouldn't be like the gauntlet you have to get through. It should just be a final summary of, you know, you just show you kind of remember it all. But if the students do real bad on the previous exams, then that final needs to be to clarify that you now understand it. So it'll depend on you. Does that make sense? The final will actually depend on the class and what it turns out to be. And attendance. So you are allowed, the state allows 4 absences, right? So that means life can happen. You can find marijuana in your door panels and need to have K9 units search your car, like, right? Those of you who walked in late, just don't even worry about that story. That can happen, and you miss a class. You can miss 4, right? You're sick, you can miss 4. Life happens, right? But after the 4th absence, you will basically be handing your grade over to me, and it'll be my discretion. I can drop you, or I can fail you, or I can let you proceed in the class. It's really up to me, and this goes for me and all instructors. I didn't make this policy up. So keep that in mind in all your classes, that after that 4th absence, you kind of lose control of your destiny a little bit. So the way I'm going to do attendance is I have this folder here, and what I'll do is I'll pass it around. It should have your name on it. If your name's not here, just write it at the bottom. I left a couple of blank slots here. Just initial next to your name on the column for the date, and this will go around every class that we meet. If I forget to pass this out, okay, then whoever reminds me will get a bonus. 1-point bonus, probably on a test. Okay, so I don't want to forget. I get real, you know, in the beginning I'm real good, and then as the semester progresses, I just start forgetting about this. So please remind me to pass this out, all right? And what we'll do is we'll just start it at one table, find your name, initial, pass it around. Make sure once you're done at your table that it gets around the whole room. Now, another thing about attendance, when I was first when I first started college, I went to, I remember not in the very beginning, but I went to this class. There were, I think, 280 students in the auditorium. And the professor was up there, and she was like, there are 280 of you here. I expect to see 40 of you at the final, and maybe 20 of you will pass. I was like, well, you know, odds aren't in my favor there, so I just decided not to go back. I just never went back to that class ever. And so I assumed, look, I went there one day, never went again. You know, I shouldn't get an F for that, right? I mean, but that's what happened. I got an F at the end of the semester. Why? Because she didn't drop me. And, well, I learned the hard way, that's not her responsibility. It was my responsibility. So same thing with you. And this goes for this class and all of your classes. If you just stop going and you're like, oh, but I'm past the 4 absences, I'm going to get dropped, don't assume that. Because instructors very rarely will actually take the time to go undo your registration, right? Like, I didn't call any of you before the semester, right? Say, hey, come be in this class, right? I didn't go and force you in here, so I'm not going to go necessarily, you know, get you out of here either. You've got to do that. So just be aware of that, all right? You don't want to be here, just go through the process. If you just send me an email and say, please drop me from your class, I will do it. But I have to have some sort of official, you know, request. Questions on attendance? Okay, let me talk about this lab. Right across the hall, right here in the corner. There's a big room. It's, where is it? Room 316. You must go into that lab on your own free will when you have breaks, and you have to log in with your banner ID, and you have to log 800 minutes over the entire semester, which breaks down to, you know, like 13 hours or something like that. 13, 14 hours. So that's like, it's like an hour a week that you're supposed to go to this lab. And what you do in that lab is you sit down at a table, you break out your binder with your book in there, you do your homework, right? You do your homework, and there's tutors in there. You can ask questions. If you want, you can form groups, you know, your students that you're in class with. Y'all get together on the same day, same time. Y'all always go there. Y'all work together, whatever it is. That lab is a place for you to get help and for you to do work, all right? If you come down to my office, I'll count that as lab also. You know, anytime you spend with me down in my office hours, I count that as lab too. But we have to be careful with that because I can't have 30 students in my office. It would be, you know, it'd be impossible for me to accommodate all of you. So if my office gets too full, some people will just have to be sent to the lab. So 800 minutes, so that's a lot. They bumped that up. It used to be 600. Last semester it was 600. Now it's 800. So again, not me, it's the state. Now, if you have other issues, like let's say you miss a class, and even though I'm recording the video and everything, you still need help, or maybe there's a test coming up and you're real anxious about it, we have a special advocacy center that's room 308, which is on the other side over here. And that room is for personal, one-on-one, 30-minute sessions, and they basically take whatever questions you have or topics you are confused about, and they work with you one-on-one. I believe you get, I want to say 5 sessions if you want. 5 30-minute sessions, yeah, 5 30-minute sessions. But you have to set up an appointment. You can do walk-in, but if they're busy, they won't be able to help you. So that's the advocacy center, all right? 2 different places. The lab, that's where you get your minutes. Advocacy center, think of it as like a safety net, okay? Something happens, like I said, you miss class, you feel completely lost, you go there, they try and get you back up to speed. Questions? All right, this is a big one right here. Usually students love me when I start talking about my electronic devices policy. You are required to silence and store out of sight all electronic devices such as phones, iPods, laptops, etc. The consequence for using such a device during class is a 10% penalty on your next exam. You will also be asked to leave class for the day, and absence will be recorded. So I have a very strict policy on sitting there texting or doing whatever you're doing on your phone during class. And I always have students who are like, well, this is college, and I'm paying to be here, and I'm an adult and can't tell me what. And I kind of see that. I kind of get that, but at the same time, um, you know, it's my job to create an environment that's the best environment for everyone to learn. And when you have someone sitting there texting, they're totally disengaged from everything. It doesn't help the whole here, okay? So my policy, and as long as the district and the state allows me to make my own policies, that's my policy, all right? One day they may take that away from me and, whatever, but right now that's my policy. So let everyone know, okay? Let all your friends know that between, 9:30, 10:45, Monday, Wednesday, you are off the grid. You are in the math class, all right? I think that's fair. Now, I don't do warnings on this. Someone in here will be the first example, and it'll be just like, everyone will be like, holy shit, he really is serious about that. Like, I'll just sit, put it away, 10 points, bye, and that'll be it, okay? And hopefully that will convince everyone that I'm serious about that, okay? Now, if you are expecting an important phone call or a text or something like that, if you talk to me before class and say, hey, my sister's about to have a baby and I'm waiting for the text, that's fine, okay? Just talk to me about it. What I'm talking about is the stuff where people are just like messing around on their phone. And don't try and hide it either behind a bag or under. I know people can like text with their toes, and be writing math, and they're sitting there texting their friend with their toes. I mean, I see all that. Don't try and hide it. That even makes me more upset when you're trying to hide it. Behavior policy, these are rarely issues I deal with. Sleeping a little bit. Sleeping or being disruptive results in a 10% penalty. Same thing. So disruptive doesn't happen as much. But sometimes I've heard these horror stories in other classes where there's like one student who just like always interrupts and talks over other students. Things like that. If you're disruptive, 10% penalty on your next test. Sleeping, I know it's hard to stay awake in a math class, but if you're real tired, get up, go walk outside, go bang your head up against the wall, do a couple of jumping jacks in the hallway, whatever it takes. Don't fall asleep in here. All right? I'd rather you just get up, walk out, go freshen up, throw water on your face, come back in than to fall asleep in here. All right? I mean, just think about it. You're asleep, right? And I'm sitting here teaching. I see you asleep. And the students around you are sitting there going, this guy just lets people sleep in his class. Like, to me, I walk by rooms and I see teachers and there's like students sleeping. I'm like, what the hell's going on there? Why are students sleeping in their class? Like, to me, that's very unprofessional to let people sleep in your class. This is in high school. So you'll be asked to leave. Oh, wait, I didn't put leave. All right, you get 10 points off, but you don't have to leave. But you have to wake up, all right? I always recommend that if you're real tired, like the night that I tried to clean that car out, I was up from 11 p.m. is when I started. I finished at 5 a.m. The next day I was just done. I couldn't do anything. I was so wiped out. Well, obviously if I had class the next day, best thing for me to do would probably be not go. It's better to just get rest, sleep up, especially if we do wind up doing these videos, you at least have that, okay? And the videos are in no way a substitute for being here. You still have to be here, all right? 4 absences is all you get. You can't be like, oh, well, I'll miss and I'll just watch the video, and I still keep track. Questions on behavior? Scholastic dishonesty, that has to do with cheating. Basically, what the code of conduct says at this school is that if you cheat, no matter what it's on, quizzes, test, exam, whatever it is, plagiarize, collusion, anything, the consequences are left to me. The instructor gets to determine what the consequence is. So if I just give you a little quiz and I say, all right, everyone work by themselves, and you're sitting there helping each other out, I can just say, okay, you 0 on that quiz, or I can say, you know what, 20 points off your next test, or I can say, goodbye, don't ever come back, you're getting an F in the class. It's up to me. I determine that. And so usually my protocol is just goodbye, and it's an F, and just I don't tolerate it. So it's not, no quizzes worth cheating on. There's nothing in here that's worth the consequence of that. All right, so just take the low grade and move on if you don't know the material. All right, tutoring. I already talked about tutoring. 6-drop rule. I won't get into that. That has to do with college level courses. This is not a college level course. But once you get to college level courses, that rule applies. And then we have the SOBI statement. And I always feel weird talking about this, especially because I'm recording it. But the SOBI statement is about behavior, and there's a whole, like all these websites and stuff that we have. My interpretation of the SOBI statement is just that we need to pay attention to the people around us and things that are happening. You know, this crazy-ass society that we live in, right? You hear these horror stories about people going and doing crazy things, shooting up, you know, elementary schools, and then afterward you hear about, you know, people are like, oh yeah, you know, he had been talking about doing this, or she had been talking about doing that. You know, it's like, well, why didn't anything happen? I think this SOBI thing is about just paying attention to what's going on around you. You know, if you see, if you have this person in this class that just, you know, this class or another class that they're just off a little bit, maybe just go talk to your professor. Just go talk to someone to say, you know, just so people are paying attention to these things instead of just saying, ah, it's okay. And with that wonderful thought in mind, I always like to talk about what our options would be if, for some chance, there's an active shooter in the building. Okay, y'all know what I mean? Okay, we start hearing gunshots. It seems like it's right outside this hallway. You know, I haven't looked. I'm about to look. We're about to see if we have a way out through these windows or not. We're on the 3rd floor, so I don't think this is going to be good. The other side of the building has like an awning that you can jump onto the awning and then go off. Let's see here. I think I've been in this room before, and it's not good. Yeah, it's not good. All right. Well, I'm pretty sure that's a fatal fall right there. Yeah. That's got to be at least 30 feet, and it's concrete. There is one tree here. There's one of those, like, there is a tree that you could jump into. I hate to think about that stuff, but I mean, I like to know. I like to be prepared. What I know now is that if there is an active shooter, I don't have an exit, okay? My only way out is that door. So this is basically a room that I would have to barricade. We'd have to barricade ourselves in. So that means all the tables would go up against that door. That sort of thing, right? Hey, I mean, I was wired that way from my dad. I don't know who else does this. You go to a restaurant, you sit, you face the door. Who else does that? Okay, all right. I was taught anytime you go to a public place and you're going to be sitting down or something like that, you always face the door, the main entrance, and you always have 3 outs. You need to know where 3 exits are. That was my dad. That's what he taught me. So, you know, to me, there's a quote, and I always mess it up, but it goes something like this. Luck is preparation meets opportunity. So in a situation where, you know, someone gets out of something like that, if they're prepared, like if I knew right now that out this door was an awning and all of a sudden someone starts shooting, and you see me grab a chair here, throw it through here, and I'm out the window, and you're sitting there going, what the hell? You know, like I knew, I was prepared. I went. I knew what to do, you know? It's better than just being like, you know, I mean, you don't want to be that. You don't want to be the person in the fetal position in the movie theater waiting, you know, just waiting for your turn. You know what I'm saying? You don't want to be that. Unfortunately, on college campuses, you can't carry concealed, right? You can't carry concealed weapons here. You're not supposed to. So anywhere you can't carry a weapon is a place that people could possibly target, right? All right, well, we just have to be real, right? We live in a crazy, crazy world. So I guess that table right there, you're going to hold the door for us, right? All right. All right, we won't have to worry about it, but all right, here's our schedule. This is what we're supposed to do. And I've been yapping so much, I'm not sure we're going to be able to do 2.1 today, but we'll start it. So the way the schedule works, you know, we have the date, we have the chapter, the section. So this is chapter 2, section 1. That's what 2.1 means. And we're going to do this, and then we're going to move on, chapter 2, Then we have a review. So we do have reviews before every test. Okay, we do have a review. I recommend you attend that review. Exam, and then we come back, boom, boom, boom. We have a review. We have another exam, and then we have a spring break. a week off, right? Then we do some more, then we have another review and exam, and then we have last day to drop the class. You get till April 21st to say, you know what, I don't want to be in this class anymore. That's a long way down there. And then you have exam 4. Notice exam 4 does not have a review. Okay. And then after we finish exam 4, we come back for that final Wednesday. We do a review for our final exam. And then Monday, this is considered finals week. May 12th is when finals week starts. We have no class on Monday and our finals on Wednesday. Okay? That's the way finals work. You should only meet one time during finals week for your classes, and it should be the final. Everything else on this syllabus is stuff that I didn't put. It's put here by the district or the college, so I'll let you read through that. There's something here about an associate's degree. Just talks about, you know, if you're kind of one of those students that don't really know what you want to do, it might be worth it to at least try and go with an associate's degree, a 2-year degree. And then from there, you can go do a 4-year if you wanted to. But, you know, usually people who finish an associate's, you know, they make more money over a lifetime than people who don't and things like that and blah, blah, blah. So, any questions? Everyone clear with where the syllabus is? Yep, it's right there in ACES. Just click on our class. And once you're there, right there, link to the syllabus. Okay? Now I want to show you, again, I did this earlier, but I'm going to show you my other class. Okay, my other class, they have the lecture video, right, that I told you I put up there. And then over here on the left side, there's something called files. If you click on files, what you'll see here is the Day 1 PDF. So my students can click on that. It's downloaded here. Let me show you what that is. That's everything I wrote down in that class in a format that they can print off. So it's located in the files of the class. And normally, every time I put a video up or I put a file up, I usually don't let you know. I just kind of put it there, you know. So you just want to be going in there every so often, just checking, you know. After class, it usually takes about, like, I'll walk down to my class, I'll hook my computer up, I upload to YouTube. The video is usually there within 20 minutes of this class being done. The video will be there, and the notes. So you can go in there and check it out later on today or whatever. What, the video? Well, the video, let me show you the video, because there's 2 ways to play the video. If you click on this little icon right here, it'll actually play the video in Canvas. Okay, I'm going to mute it. But that's playing inside of Canvas. I don't really care for that because I can't control the size of the player within Canvas. So I don't recommend that. If you click on the link to class lecture videos, what it does is it takes you to my YouTube channel, and then it has the playlist over here. So you can see over here, the only thing I have for them is Day 1. Okay? Now, if you click on Robert Math Guy, I think, well, no. Oh, yeah. Well, I don't know how you get to. I don't really get on YouTube too much. Let me shut me up here. I'm annoying myself listening to myself. There is a way that you can just click on me, and this will bring up everything I have. So I have playlists for, I just started doing this last semester. I started putting them on YouTube, but I have like several years worth of videos. I used to do videos on camera, but the equipment was too bulky to carry around. So, you know, there's nothing here really for you to go back and look at, because I don't have anything from like 0300 or 0301. I only have like 0302 stuff, 0303, and then college algebra and calculus, and so. But you could get to my YouTube channel here. I know some students are familiar with YouTube and they want to subscribe to my channel. That's fine, but you're going to probably get notifications every single time I upload a video for all of my courses. So that might get annoying. All right? Any other questions? No? Okay. So here's what we'll do. We're gonna get started. All right. Let's first determine, is this okay as far as lighting? Do we need a little more light, or are we happy with this light? What do y'all think? Too sleepy like this? Because there's kind of this weird point where the glare gets too much and you can't see the projector anymore. Let's try this. All right, so I'm going to start in 2.1, and one of the drawbacks to this whole restructuring done by the state is that what we've done by kind of cramming two classes into one, we've also broadened the scope of what a student knows in this class. So there could be a student who just barely missed out on 320. So you know a lot more than a person who just barely got into 310. So we have a wider window of what knowledge you have already. That's kind of a dangerous point. So I might start doing this stuff and you're like, are you serious? Are you serious? I know this already. And that's fine. Trust me, it'll pick up. You just got to stay on top of it, all right? Just if you know it, just pay attention to things like the way I write things, neatness, logical steps, things like that. All right, 2.1. We are going to talk about addition, subtraction, multiplication, and division properties of equality. So I'm just going to label this instead 2.1 properties of equality. How does that look, everyone? Is that legible? I'm going to try this. I've been using this for, like I said, about a year, but I usually haven't been using the wireless part of it because it's kind of awkward to walk with this, but I'm going to really try this semester. That way I'm kind of in your face a little more, and so it's not just me in the corner of the room and everyone's looking up there. It's kind of weird. Ooh. Okay, properties of equality. So let's say that I have something like this. 4 equals 4. Does everyone agree with that? I mean, equality means that the left side is equal to the right side, right? So that is true. Everyone would agree. Now, anytime we have equality, we can always add the same thing to both sides, and we still maintain equality, don't we? So like if I take this and I say, here's my 4, and I add 2 to that side, and then on the right side, I do the same thing, I will still maintain a true statement, won't I? And it does not matter what I add to both sides. That will be true. So this is true also. So what we get is our first property of equality, which states that if we add any number to both sides of an equation, we maintain equality. Have you all heard that before? Add anything, both sides, still same, subtract, same thing. So we have those two properties. So let's go ahead and put those. Let's put that property on there. I'm going to put the addition property. That's not the way you spell addition. Okay, the addition property says if you add any number to both sides of an equation, equality is maintained. Now that goes for any equality. So let me try something a little different. Here's another example. I'll label this one with an example. What if I tell you that x equals 4? Now we've introduced the letter x, right, which we call a what? A variable, right? We call this a variable. And what we're saying here is that x is equal to 4, right? X is equal to 4. But if I wanted to, I could add anything to both sides and maintain equality. So let's add something. You pick. I don't care. What do you want to add? Not all at one time, please. Raise your 5? Okay. Okay, so let's take this x. Now I'm going to add 5 to the left side. And then on the right side, I'm going to take my 4 and I'm going to add 5 also. What that would tell me is that x plus 5 equals 4 plus 5, right? That should still be true. Well, can we put x plus 5 together on the left side of that equation? Can you put x and add 5? Does that combine in any way? No, those are not what we call like terms, right? Y'all heard that before, like terms? So we cannot put these together. So all I have on the left side is x plus 5. And on the right side, I can combine 4 plus 5 to get 9, right? Now, both the examples I've done so far is just kind of like, yeah, and like, what's the point, right? The only thing I'm trying to express to you is that anytime you have an equation, you can add anything you want to both sides, and it doesn't mess anything up, right? Look at that bottom line we have there. If I take the 4 that I had before, when I said x was 4 and I put 4 right there, that's a true statement, isn't it? 4 plus 5 is 9. So it still maintains the equality. All right, now let's do an example that would be more geared towards where we're going with this. Another example would be, what if I have x minus 3 equals 12? What I'd like to know is, what is x? Right? Can you tell me what x is that would make this thing true? Like, what number would I replace for x there to make this a true statement? 15. Now, you could probably do that just by looking, right? Like 15 minus 3 is 12. But in math, we need a more systematic approach. We need something that's going to work all the time. So what I'm going to do is I'm going to use the addition property, and I'm going to try and add something to both sides of this equation. And in doing so, what I want to try and do is I want to try and isolate this x. I want to get that x by itself, all alone. Right now, the x has the minus 3 there. So what can I do to get rid of a minus 3? Add 3, right? Okay, but if I add 3 to a negative 3, I have to also use the addition property, which means whatever I do to one side, I have to do the other. So what I'm going to do is add 3 on both sides. Now, there are two ways to do this. There's called the vertical technique and the horizontal technique. What I've shown you so far has been the horizontal technique. Every time I've added something, notice I added it in the same line instead of like below it. Most students learn the vertical technique. So I'm going to show both, and then we're going to take a vote, and whichever we have more of, that's the way we're going to do it, all right? So here's one way. We're going to add, what did we say we're going to add to both sides? Okay. If I write x minus 3, that was the original problem, I'm going to add 3 to that side equals the 12, and then I'm going to add 3 to this side. Now below this, I'm going to put or. This is the way a lot of students do it. They take the x minus 3 equals 12, and then they add 3 vertically, so below it like this. All right, let's take a vote. How many of you do it the top way, horizontally? Okay. Bottom? Everyone else? Okay. I recommend you do what you're comfortable with. In fact, the horizontal is actually better for like just working from line to line to line because everything is nice. Everything's on one line. When you do the vertical, you start creating like new lines that aren't really part of this line, and it's mathematically it's not as elegant as far as the writing is concerned. But most people learn it that way. Let's just stick with that then. How many of you put a line below when you add? Anyone do that? A few of you? I normally don't, but you feel free to do it, okay? So let's go ahead and add down. Unfortunately, I'm out of room, so I'm going to have to go to a new page, all right? So you go ahead and add down while I go to my new page. Oh. And you should get, hold on, this thing is acting kind of funny. Do y'all hear that sound? Sounds like a washing machine or something, right? That would put me to sleep if I were in here. I'd be all. All right, so what is the negative 3 plus 3? They cancel out to be 0, right? So what is still there on the left side? X. And then over here, 15. Okay. Now, again, you could sit there and be like, all right, come on, man. I already knew that. I could look at it. I could figure it out without doing all those steps that you just did. But the problem is that if the problem becomes more complicated, you won't be able to do it. So we have to have a systematic approach. All right, let's now talk quickly about the subtraction property. All right, if we can add something to both sides and it still maintains equality, then subtracting should do the same thing. So subtraction. What did I call the other one? Let me go back real quick. Addition property. Yeah. It basically says, and I'm not going to write it out like as in full detail as I did the previous one. I'm just going to put, if we subtract both sides, equality maintained, okay? If subtract both sides, equality is maintained. And we'll move right to an example. Okay? What I'd like for you to do is solve for y. So I want you to get y by itself. So I'm using a different variable instead of x, right? I'm using y. So how could you get that y there by itself? Subtract 7 on both sides, right? Now, we seem to most of us be happy with doing it vertically, so go ahead and let's set it up vertically. I'll use blue here. I don't want to let blue feel like it's being left out. Subtract 7 vertically, and I'll put the line there just for those other people who do that also. On the left side, my y just stays. My 7 minus 7 is gone, right? Cancel that out. And on the right side, sign numbers, 4 minus 7, negative 3, right? Negative 3. So what is the left side of this equation? Left side is y, right side is negative 3. And that's it. Y is negative 3. I think I forgot to box the answer in the previous one. I should do that. So, I mean, the whole idea here, and a lot of you knew this coming in, Anytime we have an equation, you can add or subtract any number you want from both sides of the equation, and it still maintains the equality. Now, let's get into the multiplication and division property. I'll start with multiplication property. What do you think the multiplication property says? Addition property said I can add anything I want to both sides. Subtraction said I could subtract anything I want from both sides of an equation. Multiplication property, what do you think? You can multiply both sides of an equation by anything? Almost. Multiplication is the one we have to be careful with. Well, and division. We cannot multiply by 0 because what's anything times 0? Itself. So what happens is if you multiply both sides of an equation by 0, what happens is you get 0 equals 0, and it's always true. So you actually wipe the entire equation out. So you can multiply both sides by anything except 0. You lose all information. Let me just show you a quick example. If I write 3 times x equals 9, can everyone tell me what x is? 3, right? Because 3 times 3 is 9. But what if I multiplied the left side of this by 0 and the right side by 0? What would I get? Left side would be 0. Right side would be 0. That's true, isn't it? But it didn't tell you what the answer was. You see? All it did was just wiped everything out. You have no information now. So we can't multiply by 0 or else we just eliminate everything. Does that kind of make sense? All right, I'll leave that up there. Let me just put a little space in here. Okay, multiplication property says you can multiply by any number other than 0 on both sides and maintain equality. And what do you think the division property says? Same thing. Do you think that with division we have to also throw out 0? Yes. Because remember, well, maybe you don't remember, but there's one number in math you can never divide by, and that's 0. We'll talk about that more in a second. Like, why can't you divide by 0? Okay, so I'm going to put the other property below this, and then I'm going to start doing a couple of examples. Division property. Divide both sides by any number other than 0. And maintain equality. Y'all hanging in there? I mean, this isn't necessarily your idea of fun. I understand that, but doing all right? Okay. So let's see how we can use that on the problem that I had put up here, and we had messed up by doing zeros on both sides. So if we do an example, 3x equals 9. Again, the goal here is to try and get the x by itself. Right now, that x is not by itself. What's sitting there with the x? The 3, right? The question that you need to be able to answer is, what is the operation between the 3 and the x? When you write 3x, what does that really mean? Multiplication, 3 times x, right? So what I'm going to do is, in here, I just want to kind of highlight this. This right here really means 3 times x, right? 3 times x, that's what it means. So the way that we undo multiplication is to come in with its inverse, and the inverse of multiplication is division. Just like when we had a plus 7 or something, we subtracted 7, or if we had a minus 7, we add 7, something like that. The opposite or inverse of the multiplication operation is division. So I'm going to divide both sides by 3. So I'll write it down, and I'm going to do it vertically again. 3x equals 9. I'm going to divide the left side by 3, like this. Divide the right side by 3. I'm hoping most of you have seen it done somewhat like that. That fair? Now, what is the 3 over the 3 on the left side? It cancels out. And remember, that's because 3 divided by 3 is 1, right? Any number over itself is 1, and 1 in front of anything is itself. So 1x is still equal to x. So that's what I'm doing on the left side here. So the left side is just going to become what? X, and then 9 divided by 3 is 3, right? Okay. We're going to do another example here. Now we're going to start putting it together. Negative 5x plus 7 equals negative 8. All right, we are now starting to get into something more complicated. Now we've got something that it's not as easy to just look at and tell me the answer, right? Our goal here is to solve this. Next class, we'll talk about what these are called. They're called linear equations and blah, blah, blah. We'll talk about it next class. We are going to solve this. To solve it means what? When I say solve, it means x equals something, right? Tell me what x is. What do I plug in for x to make this equality true? Can anyone just look at that and tell me what it is? Just by looking? Probably not, right? 3? Yeah, I think 3 is going to work. So let's do it. How are we going to get the x by itself? The standard technique, I'm going to give you a set of steps at some point, but we always want to get the x to be by itself by first taking away anything that's being added and subtracted on that side. So the only thing being added or subtracted is what? The 7. So how do I take a plus 7 off that side? Subtract 7 on both sides. So I'm going to subtract 7 on the left, subtract 7 on the right, and let's talk about what's left. What still remains on the left side of this equation? Negative 5x, so I'll write it down, negative 5x. Don't forget the good old equal sign, bring it down. Negative 8, take away 7, negative 15. Now, if you ever in this class are sitting there not understanding a step, you either need to stop me or you need to put a little like asterisk or something on the side and then come after class or something, come down to my office. Hey, I didn't get this step, if you could help me out, all right? Just don't be like, oh man, I have no idea, and then when you come for help, you're like, I don't understand what you did, but I don't know, I don't remember what it was. You know, try and at least keep track of what you're lost on. Okay, good. Now this remaining equation, we still almost have the x there, but we have a negative 5 in front that's being multiplied, right? So how do we undo the multiplication? We divide, and we divide by whatever we see out there, right? So I'm going to divide both sides by negative 5. Divide by negative 5. On the left side, negative 5 divided by negative 5 gives me a 1, right? 1 times x gives me x. So I have x on the left. On the right, negative 15 divided by negative 5 is what? 3. And let's remember, when it comes to multiplication division, if they're the same sign, the answer is positive. So if you multiply 2 negatives together, it's positive. If you divide 2 negatives, it's positive. So your answer is 3. All right. How's that? Is that okay? All right, I'm not going to do another one, but I want to just talk real quick about why can't we divide by 0? Have you ever wondered why we can't divide by 0? Probably not, right? It wasn't really high on your list of things to figure out over the break. Yeah. You didn't leave that, for Santa. All I want this year, Santa, is to know why you can't divide by 0. Well, let me just explain why it doesn't make sense. Okay, I'm not going to really get into the technical part of it, but let's just talk about what a fraction is. If I write 1/2, right? Then most people understand that visually, right? I could take, let's say I take a candy bar, and I say half of it, then that would represent that part right there, right? The yellow part. That would be half the candy bar. And the numbers that we have here can be matched up. The 1 and the 2 are somehow represented in this picture. The 2 is how many pieces I have, right, to choose from. Like I have 1 piece, 2 pieces, right? And then the 1 on top is how much I take, right? I took 1 of those 2 pieces. That's what 1/2 means. If you go that same logic, what does 2/3 mean? Well, we take candy bar, right? We take it, we cut it into how many pieces? 3, and we take how many of them? 2 of them. 2 of the 3. So that makes that usually makes sense to most people. We okay? All right, just follow me on this. Now what I'd like to look at is 0 divided by, let's say, 3. Now, remember, the bottom is how many pieces I cut it into, right? So I should have 3 pieces. And how many am I going to take? None, which means I should have how much? If I say, look, here you go. I'm going to take this candy bar for you. Here's 3 nice pieces. You get none. Then you get what? Then how much do you have? Nothing, right? 0. So 0 divided by 3 is 0. It's like I cut it up for you, but I don't give you any. So you don't get any, and that's it. You're screwed. You get 0, right? But it's defined. It's okay to have 0 divided by 3. That's okay. The answer is 0. The other way around, let's look at why it doesn't make sense. 3 over 0. 0 is how many pieces I'm supposed to cut the candy bar up into. Well, my candy bar starts out, it's 1 piece, isn't it? I can cut it, and that would be 2, and I could cut it again, that'd be 3. Cut it again, that'd be 4. But this is saying I'm supposed to have 0 pieces. But I start out with 1, and then I'm supposed to take 3 of the none. It just doesn't make sense. That's all I want you to see, is that if you look at fractions as candy bars, everything makes sense except when you put zeros on the bottom. Okay, let me look at what I could possibly assign for homework. Every time I assign homework, it'll be at the end of class, and it'll always be based on what we did, because I can never predict how far we're going to go, especially since this is the first time I've taught this. Let's see. These are probably... page 110, I'd like for you to do 15. This will be interesting. 15 through 33, odd. That's the way I write odd. I know it looks odd, but that is the way I write odd. Odd is like one of those words I just have never been able to write it nicely. Guess I could use lowercase d's, but okay. And then I want you to look at let's do this. Go 15 to 53 odd. Now that's quite a few problems. And I can already tell you there's going to be problems in that homework set that are not like what I did in class. In other words, There's some fractions in there. There's some decimals. What I want you to do is attempt as much as you can from that. What you don't understand, you come to class or you get help or you come to class with questions. That way I can start class out next time and be like, all right, homework questions. And I know there should be some, all right? Now, the book, the reason I'm cutting out now is everyone can just walk down the stairs. I'll kind of go with y'all, and we can just go grab the books. We'll hand them out real quick, and then you can be on your way. All right? Any questions? Remember, I'm going to be in my office from now until 1 o'clock if you need to talk with me. Can someone hit the lights on their way out?